Across highways, truck stops, and depot bays, something is quietly shifting. The shift towards zero-emission trucks isn't just an idea anymore. It's already on the ground. Pilots are running, technologies are evolving, costs are reducing. Drivers are happier, and the questions are getting more real every day. This is GET ZET, an initiative by the Center of Excellence for Zero-Emission Trucking. In each episode, we dive into the rise of ZETs, from charging time to finance, and from safety to pickup improvement, and the real-world impact of it all.
Heavy-duty trucks are just 2% of the total vehicle population in India, but they consume as much as 40% of the fuel in India, and 40% of the emissions are also from these vehicles. So what's the solution if you want to cut down on fuel consumption and cut down on emissions? So this is a complex journey, and it's not a simple, straightforward solution. IIT Madras has set up the Center of Excellence for Zero-Emission Trucking. We call ourselves COZET. And COZET has been working with the field and the OEMs and the government to enable this entire transition to zero-emission trucks over the coming years. A lot of efforts on different fronts are being made to promote zero-emission trucks in India, and we are going to focus primarily on the electric trucks this time. So electric trucks are in a position to completely transform trucking in India. Not just about a superb experience for drivers with less noise, less heat, no clutch and no gear shift, but also superior driving speeds, better pickup, far less emissions. So these are going to make a massive difference to the transportation sector in India over the coming years. So whether you're part of the industry moving goods, or whether you're somebody who is outside the industry, it is going to impact you when the transition to electric trucks happen. It's just that whether you're impacted directly or whether you're impacted indirectly. So is the transition going to be easy? Is it going to be simple? No, it's going to be fairly complex, and it's going to have a lot of challenges. But we need to face these challenges if we want a better life. So joining me today is S.A. Sundaresan. Most of us call him Sundu. He is currently a professor of practice in IIT Madras. And prior to this, he was the head of new technologies for Ashok Leyland as a vice president. Sundu has worked with different types of zero-emission truck technologies, whether it's hydrogen fuel cell, whether it is electric trucks. More importantly, Sundu has been evaluating the options as they have been evolving. He's kept a close watch on costs, how they pan out. He's kept a close watch on safety. He's kept a close watch on performance, what user requirements are, what is the typical range that is required, how much time is available for charging, and what are the unknowns, things which we do not yet know for sure. So we've got someone with us who's done in-depth analysis in this entire area. So thank you, Sundu, for joining us today.
Thank you.
I'd like to start off with a fundamental question for our viewers. What exactly is zero-emission trucking, and what are the various technologies which are enabling zero-emission trucking, not just in India, but globally as well?
Sure. I think the question is a very important one, because there's a lot of confusion in the field about this. So zero emission, when we say a vehicle is zero emission, we are talking purely about the tailpipe emissions. What happens when the vehicle is running on the road? We really do not consider what happens when let's say the vehicle is getting produced, or the various parts of the vehicle are getting produced, or how the fuel or the energy for the vehicle is getting delivered, whether there is any emissions because of that. Ultimately, as long as the vehicle, when it is running, there are no tailpipe emissions, it is a zero emission vehicle. Now, some people relax this definition to say only, even if there are other emissions, but there is no carbon dioxide emission, it is still called a zero emission vehicle. It's a matter of debate whether that's okay or not. But considering the adverse implications of carbon dioxide, I think that definition is also okay. So we can call any vehicle that has zero carbon dioxide emissions as a zero emission vehicle.
How do you see them when you compare it to the combustion engine, specifically the diesel trucks? How is their performance? How is their safety? Is there any specific application today where it already makes sense to electrify and go ahead and electrify because the costs are okay? What's your observation and what's your take on this as a comparison to diesel?
See, let's first look at the powertrain or the engine, whether it is an internal combustion engine or an electric motor or engine. So if we really do the analysis from the application perspective, the kind of torque that engine should develop at various speeds, we actually get some shape which is nowhere close to what a diesel engine delivers actually. And we make up for that by adding other components like a gearbox. Only with a gearbox, a diesel engine can actually drive a vehicle. But unlike that, an electric motor naturally has that what is called the torque speed curve, which is ideally suited for a vehicle. What do we want? At launch, we want maximum torque. That is when the vehicle is taking off from being a completely stationary object. It is picking up and moving. So that time you need maximum torque, and diesel engine never delivers that torque. The peak torque comes at something like 1000 rpm, 1500 rpm, 2000 rpm, whereas electric motor can deliver that peak torque at 0 rpm. So in terms of launch capability, electric motor is a perfect fit to drive a vehicle. Then when it comes to efficiency, again, we all know from thermodynamics, anytime you're converting energy from one form to another, there is a natural loss. Now, especially if heat is involved, by nature, it is lot of it is irreversible. So again, efficiency suffers. So a diesel engine, the minute we start burning the fuel to get it to first that thermal energy, release that chemical energy inside the fuel and convert it to thermal energy, and then to mechanical energy, and then finally transmit it to the wheels, it's only about 40%, 45% efficient. But if we look at electrical energy, it is already a higher form of energy. So converting just that into mechanical energy is a lot more efficient. So again, as long as we look at it from, let's say, tank to wheels kind of efficiency, electric vehicle efficiency is at least double that of a internal combustion engine efficiency. So combined with, and then there is one more advantage that comes, especially in a country like India, where traffic is, you never maintain a steady speed. There's always acceleration, deceleration. And whenever you decelerate in a regular internal combustion engine, you are just losing that kinetic energy. You're applying brakes, converting that kinetic energy into heat, and again, losing all that. Whereas in an electrical vehicle, you can recover that kinetic energy that is adding anywhere between 15% to 30%. You are able to recover that and feed it back to the battery. So in the entire process, a EV is lot more efficient than a internal combustion engine. Then when you look at what this combination of the ideal torque speed curve and this regenerative ability is that, number one, the driver finds the vehicle far more responsive both to the traffic and to his driving intent. We have seen drivers, when they drive an internal combustion engine, struggle with the gear shift. When do you shift the gear? And you do it too early, then you get a big jerk. You do it too late, then the vehicle simply has slowed down. Whereas all that is kind of eliminated on that. And on top of that, your efficiency, that kind of results in getting more mileage out of same single rupee of whatever, whether it is fuel or electricity. Safety, there is a concern based on whatever past experience that people fear that battery electric vehicles are not very safe. But again, it is more because the media attention to a single incident that is happening. In terms of statistics, if we look at such incident per vehicle, per number of vehicles on the road, or even per number of kilometers covered, all that, every statistic says that electric vehicles are much safer as compared to internal combustion engine vehicles. But all that said and done, there is scope for making electric vehicles even safer. And already China has taken the lead, and the kind of standards China has released for batteries make them like pretty much nothing can happen to the electric vehicle. Whatever happens, it will remain a safe vehicle on the road, and it's only a matter of time before everybody else in the rest of the world adopt those same standards. So we are going to set up actually a standard where internal combustion engine will find it very difficult to reach that level of safety.
I see. I didn't realize that this new standards were coming, which will make it so safe. As of today, if you look at the heavy vehicles, right, let's say 12 tons to 55 tons, there must be about 200, 300 trucks on the roads today in India. Are you seeing any use cases where operationally electric trucks are becoming more attractive? And second, financially, electric trucks are becoming more competitive than diesel. Are you seeing any segments which are evolving where there are advantages on these two fronts? Could be just one of them, could be both of them.
Sure. No, operationally, both the drivers and the fleet owners find electric vehicles attractive. The drivers find it attractive because of the overall comfort and, as I said, the drivability. Anybody who has driven an electric truck says ideal, given a choice, they would not go back to an internal combustion engine truck. Not just the cabin comfort, even the way the vehicle responds to the driver intent. That is what they like a lot. And then why do fleet owners like it? Turnaround time. So both in terms of, because of that torque speed curve being ideally suited for a vehicle on the road, the acceleration and you are able to quickly reach, and then because of braking you are really not losing all that fuel economy. So for all those reasons, overall both the turnaround time and the operational getting more mileage or better fuel efficiency is easier with an electric truck as compared to a internal combustion engine truck. Then in terms of money aspect, yes, the upfront cost is high, but as long as enough kilometers are covered per day or per month or per year, so to offset that higher initial cost with the higher savings in the operational costs, it makes money sense today. So there are different numbers. So on an average, if you run, let's say 300 kilometers a day, or typically about 30,000 liters of diesel over the year kind of a time frame, if you are spending that kind of fuel, then it already makes money sense for the electric vehicle.
I've heard that if you're spending about 27 to 30 lakhs per year on diesel per truck, you don't need the subsidy, you don't need the toll waiver, you just have a business case already. And the only reason you're not able to start with an electric truck is because there are not enough lenders who are willing to take the risk on the resale price and also the charging infrastructure. So money, if you're burning enough diesel on an annual basis, I think you have a business case already. There are so many issues or constraints for e-trucks to take off today, right? So you've got the charging infrastructure part, you've got the upfront cost, both for margin money as well as for the debt, right? There is also the hidden fear of new technology, right? It's a latent thing. I hear that there are a lot of solutions which are being provided by the OEMs which cover the technical risks, but still the fear is there. So there are a lot of these limitations or gaps or disadvantages, either really or as perceived, right? It might not be true, but people see it as a problem. Do you see all these going away over time? And if you see them going away, what's the time frame you think? Is it going to be 5 years or a decade or 15 years? What's your personal opinion on this?
See, I think most questions will get answered if people see these vehicles in operation for about 5 to 6 years. In terms of technology, today electric vehicles are quite mature. don't really, definitely technology is changing, but it is only incremental change that is happening. Gone are the days when there were like quantum leaps in technology. Already the electric vehicle technology has reached pretty much the flat portion of that typical technology maturity curve. Sure, there will be improvements, but I don't expect them to be significant. Cost wise, again, it has reached more or less it has bottomed out. There might be 5%, 10% is unlikely. Maybe year to year change is going to be in single digits. If you look at it in over a 5-year time frame, maybe you will see a 10% drop in price, 15% drop in price, but not on a year to year basis. But just that the perception and the fear of the unknown. So for that, I think people will want to see some real world data. Even whatever data you publish in terms of test data, trial data, all that, people would ideally want, okay, real world, real customer, not a OEM driven pilot, but somebody who has just bought the truck, tried it out. So once those stories start coming out, I think a lot more confidence will come. So I think it is a matter of maybe 4 years, 5 years at best. By then, enough stories will be there. People would have seen, somebody I know, yeah, he owns an electric truck, and this has been his experience. I think that will convince people.
Yeah, and two things where social media and media are not helping. One is where you see all these sensational fire videos on two-wheelers. Some of the times I get two-wheeler fire videos on my WhatsApp, which are about 4 years old. But it's catchy, I guess, so it attracts a lot of attention. But as you say, statistically, it's much lower incidents than diesel or petrol. The other one is also the news releases about startups where there is a lot of hype. So even if you're just showing a 2% improvement, the article makes it out as though it's like completely new and everything is all outdated and nothing is valid and only this is the future. And then 6 months later, that company dies, right? So it's a very peculiar situation. I guess this information overload comes with false information overload as well, right? But on this context, Sundu, the technology being new, right? And with all this WhatsApp University videos, where do you see the safety at today? Would you send your child in an electric car? As simple as that, right? And would you send your child in an electric car every single day, every day of the month? Where do you see this safety question in terms of technology in the context of trucks?
If we look at many of these incidents, of course, some have been because of bad design or bad manufacturing. Again, in the initial days, there were too many startups, and there were, at one level, the knowledge was not there. So most of these startups were just buying components without really understanding what they were buying, and there was no incoming quality control at all at these places. So whatever you were given, you take, you assemble, put it on the market. And obviously some of them had issues, and that was one starting problem. And then people say, no, even with established brands there have been incidents. Yes, there have been, but as some of these established two-wheeler brands, they have shown a lot of it is because of misuse. See, all said and done, the level of protection that is gradually kind of getting built. Initially, whatever was known, that was addressed. You had enough protection mechanisms. But then always in the real world, there are scenarios, and undiscerning customer uses it in a way which kind of opens up one more failure mechanism. And because of that, some happened, but established companies quickly plug that loophole. So they provide, see, all these batteries come with a battery management system. Battery management system is just a piece of software that is kind of sensing various things like temperature, voltage, current in real time. And depending on that, it is taking a decision. What is the right level of current or power that the battery can either take during charging or can deliver when it is running. And if due to some manufacturing defect, there is a potential failure, then just stop. So this is the kind of a decision that gets taken. Now, let's say the algorithm has not plugged all loopholes. For example, for some time you could not estimate what is the charge in the battery too accurately. So as the battery gets drained, we all know that with our even mobile phones. So if the mobile phone is towards the end of charge, it gets heated up fairly quickly. So same in an electric vehicle. Suppose the state of charge was not estimated correctly, and it is continuing to allow the vehicle to draw full power, it is going to get hot. And so that is one kind of a loophole. Similarly, during charging, when you reach the top of the charge, if you continue to charge, again, there is a risk of battery catching fire. Again, because of either sensor failures in the battery management system or the algorithm to determine how full the battery is. If there are issues, then that is where some safety incidents happen. But as the knowledge levels improve, the algorithms are becoming far better. So because of that, again, you can see the number of incidents are coming down. And again, as I said, what China has done is they keep adding to the list of test cases. Now, what they have done is for all these test cases, even if the cell inside the battery pack catches fire, the pack as a whole, there should not be even gas coming out of that. So China has realized that it is possible to control even that. So how does China have that confidence? The number of kilometers they have run with battery electric vehicles, the number of cases they have seen. So that confidence gives us confidence that we can just replicate the same this thing. To answer your question, yes, I think it's far safer for my children to travel in an electric vehicle, probably safer than in a IC internal combustion engine vehicle. And I think the accidents beyond the control of the vehicle or the driver are more in Indian context than anything that can go wrong with the vehicle per se.
Sundu, you were talking about the standards that are evolving or have evolved in China, and it seems to be a good journey, right? You learn a technology, you keep using it. More than the technology failing, the user of the technology is failing, but you have to develop standards which will prevent the user also from causing accidents or incidents. Can you tell us a little bit more about the direction these technologies are taking, one in China, how fast it's coming into India?
So both China and India, if you look at the regulation maybe a month earlier, we were on par. And the standard was that there should be at least 5-minute warning before a fire incident happens for a battery pack. So that gives enough time for anybody in the vehicle to get out. Now, what China has done is increase that 5 minutes to 30 minutes. So they say any incident, you should get at least a 30-minute warning. And on top of that, despite that warning, they say no explosion or fire can happen in the battery pack. It should be contained. So that's the new regulation. And again, India has always been looking at the trends abroad, and they will very quickly follow. See, again, just like what happened a few years ago based on the two-wheeler failures, India came up with regulations for all two-wheelers, even electric rickshaws, everything. So similarly, there's also a matter of time before the same Chinese regulation comes to India. And we'll have the same, at least a 30-minute notice. And despite that 30-minute notice is just to ensure if there are cases which we don't know as yet. But for all the test cases, no fire or no explosion is allowed. So that's a matter of time before it comes.
And regular companies would be following these standards religiously, not just during design, but also during manufacturing, etc. So, so it appears that it's a combination of initial phase of design errors and initial phases of supply chain and manufacturing quality. And also now with increased standards, these are also improving and compliance is higher. So if I were to move you by 15 years from today, right? Assuming both of us are still going to be alive. So how will this transition affect the lives of the trucking community? So by trucking community, I mean the drivers, the owner or operators, the shippers, the people who give them the transportation load, the public service people, the government. I'm talking about the related people in the other parts of the ecosystem. How do you see this affecting them?
I think driver's life is definitely going to get better. The stress, the physical exhaustion of driving a internal combustion engine vehicle kind of go away, and this is going to be a far easier vehicle to drive, just that physical exhaustion aspect. So for drivers, it definitely is going to improve. And as I said, the turnaround time or the average speed of the vehicle is already higher. The pickup is very good. So even on a grade, you should not be seeing a truck kind of struggling to crawl up a grade. So that also should not be there. So overall, the stress on the drivers is going to be far less. Now, for fleet owners, etc., it is going to, again, for them also, it is a paradigm shift. So instead of waiting for fueling or kind of worrying about fuel economy, fuel theft, and various other things, they will have a different set of problems. But the problems are probably more manageable given the technology. So you will know when the vehicle is getting charged and how the vehicle efficiency is happening. Are there levers for you to improve that fuel economy? And when to charge, where to charge, how much to charge? Those are the newer questions that will come up. They'll have to learn how to answer those to the best of their advantage. But again, all these it'll be easy. It'll be like a different set of problems, but then they will know the answers. These are not impossible to solve answers. Overall, for them, in terms of business wise, I see maintenance. Maintenance is one area where I think electric vehicles will be drastically different. So that again is opportunity for the fuel operators to be smart about it and again extract the maximum out of that. And they will not just electric vehicles. There are a lot of other technologies which are developing in parallel. One is the connected vehicle technology. Now, in a internal combustion engine vehicle, because they are used to that low initial cost, even a 10,000 rupee additional investment in a telematics device, advanced driver assist system looks like a major expense and they start worrying. But when that initial cost is already high, this is such a small percentage and it is human nature saying, anyway, I'm investing so much money. So if by paying an additional amount, the overall safety is assured, productivity increases, they will naturally go. So that adoption will also increase and these two trends will kind of combine to result in much safer roads overall. And because of safer roads, again, your productivity is going to be better. Your certainty of delivery is going to be far better. We keep talking about the cost of logistics in India. I mean, most of the time, again, it is, I guess, human nature. That's why you have the proverb, penny wise, pound foolish. We think we are saving 1 rupee, but we don't realize that cost of that 1 rupee saving over the lifetime. Now, by addressing this connected vehicle capabilities and that advanced driver assist features, we're going to realize the benefits. And again, it will take some time for everybody to know how to exploit the additional the features that are being provided. But when that happens, I think the overall cost of logistics is actually going to come down significantly.
And of course, the GATI mission is a much shorter duration. But it's good to know that logistics cost will come down over a period of time thanks to electrification. So that's encouraging to hear. Thank you, Sundu. Thank you very much for the time. Always very, very enlightening to sit with you and discuss the technical aspects. Thank you for finding the time today.
Thank you. Thanks for having me.